Good day, folks. Welcome to Bride's Mind Academy, where we bring brilliance to every lesson. Now, in today's video, we're going to be shifting to physical sciences. More specifically, we'll be dealing with physics in this particular method of. Now, uh, in today's video, we're going to be dealing with electric circuits. Now, all right, we'll be doing a concept overview of electric circuit. Right now, I want us to draw a little circuit so that we can see the things that we have to talk about. All right, now let's do so. Let's say now I have, let's say now I have, this is a normal circuit that you are used to. Okay, this is skewed. All right. Um, see now, I have A there. I have a resistor there off. Oh, is a resistor like this? I think so, yeah. Another resistor and another resistor there off. Remember now they can use a resistor uh, like this, but normally they prefer using this and naming R. All right. For now, please bear with me when I use this one. So I'm going to call this resistor 1, resistor 2, and resistor 3. All right. For now, this I'm going to call V. All right. Now we know that the voltage here, the voltage does what? Supplies what? Supplies energy. You see, the voltage supplies energy to the circuit now. But now there is what we call current. There is this concept that we call current, right? Remember what is current? Current, it is the rate of flow of charge. I think. Let me see. Yes, the current is what we call the rate of flow of charge. Now it means now if this voltage supplies now energy to our circuit, external circuit rather, it means now it's gonna do what? This energy is gonna be transferred in the form of charges, right? Yes. So it's gonna be transferred in a form of charges. All right. Now, this in what happens to this current? This current supplies power or energy from the voltage to the what? To the components thereof. In this case, our what? Our resistors. Okay. So now, let's say, let me actually remove this. Let's say now there is our current. I want you to see something. Our current comes from wherever it comes from. Then it reaches this point now. All right. It reaches this point now. In this point, what happens? Can you see that it is no longer moving in one path? So some of the current will move in this way. Let me just call this I1. Let me just call this I total. Then other part of the current thereof will move in this direction. Then we call that what? I2. All right. Then it comes thereof. It comes. This one will come to this point and this one will meet here. When they meet here, they form again what they formed. Then they now go as a whole actually, like this. It is now the total current of the circuit. So can you see here we had two different routes. We had this route there leading to that way. We also had another route in this direction. So this is very important, especially when you're gonna be dealing with a parallel as well as series, as well as the combination. All right. Yes. Now let me just draw a series circuit so that we can talk about some properties of it. Uh, series. All right, what about the series circuit? I want you to see something here of, let's say now, I have, sorry, let me just switch them off. Let's say now I have a voltage, okay, and a resistor here, okay, another resistor here. Yeah, I think let's just put another resistor. All right. Ba, ba, ba. All right. Now let's call this V, and let's call this R1, R1, R2, R3. Now, this video, it is not necessarily based on calculations and what. No, it is just based on concept. Ne? I want us to understand the concept thereof. That is here. The concept that we have here. I want to take everything here actually. Okay. And just move it a little bit here to the side. All right. Yes. Good. Now, I want us to talk about something. Let's say now, here we have our current. Let's call it I2 tan. Ne? I want you to follow the path so that you understand where these things comes from, right? So here is our path for the current supplied by the voltage, right? So now can you see that this current here is gonna come, pass across resistor R1. After passing across the resistor 1, pass on resistor R2, also pass on resistor R3, and now do what? Come back. Come back to the uh, to the main source. All right. Now, do you all agree with me that the I total in this case, let me use a different color. The I total in this case, it is equal to the current at R1 plus the current, at R2. Because why? Can you see that I'm still using the very same color here? Right here, I'm still using the very same color. It is only one path. I did not have another path maybe like this, such that my current is dividing. All right, as well as the current of I3 now, the off. This is the first property about what? About a series circuit. It is now the current, it is the same. Actually, there is a mistake that I did actually here. The current are the same. Actually, the current is the same. Let me repeat that. I'm saying the current IT from the main source, when it comes going to be supplied to our components, can you see that it passes through R1 as an I total and goes to R2 as an I total, goes to R3 as an I total, and comes back to the source. So this means now the I total thereof, it is equal to the current at R1, also equal to the current at R2, also equal to the current at R3. All right. Now, what about the current? Oh, we just talked about the current. What about the voltage? All right. What about the voltage now? Now, this voltage now, it has to come as a weighter. All right. It has to come and serve as a weighter. Now, why am I saying it should come and serve as a weighter? Now, the current here, the voltage here, should come now Remember this, all these components need to use what? Need to use a voltage, right? Need to use what? Your voltage. Now, do you agree with me that if this is V, these two other things should be 0 and 0. This other component should have 0 volts, 0 volts. Why? Because already this V is used up here. Unlike the current is just the flow of charge, where how they flow, all right? But the voltage, it is the potential difference, right? So now we're gonna say, all right, since well, let me actually give this a magnitude of maybe like 9 volts, maybe. Yes, they like using 9 volts. So now this voltage here should come and have 5 volts maybe here. Can you see that if I have 5 volts here, I still have enough what? Enough voltage to supply to these resistors here such that they can function also, right? Then let's say here we have 3 volts. Can you see that I still have enough voltage to supply the R3, which is 1 V? All right. So now here the total voltage should be shared across the what? The components that are connected in series. All right. It should be shared among them. Sorry. All right. Now I'm saying the second statement is that uh, my V total, it should be equal to the V supplied at R1 plus the V supplied at R2 plus the voltage supplied at R3. Why? Because now we are saying it is sharing among them. It is sharing among them. Do we get that? All right. The second property is here about the voltage. The third one, it is the resistance. Now, can you see that the resistors here are connected in series, right? So now if they are connected in series rather, it means now the R total will be the collective of these, the sum of these resistors, because now they are sharing a what? The same path. All right. So since well they are sharing the same path, we're gonna say now R total is gonna be equal to R1 plus R2 plus R3 plus blah blah blah. They are in they are in series. They are in series now. All right. This is still basics, right? But I'm still trying to warm you up so that uh, you remember very well when we go to broader details now thereof. All right. Let's come to parallel. Parallel. Did I say circuit or connection? Okay. Actually, I'm supposed to say parallel connection. It's fine. Parallel circuit. Now, parallel circuit now they're off. This is where the struggle becomes real, especially when we do the combination, because it always has a parallel. Now we are seeing a parallel. In this case, it is different because now, yes, we still have our voltage, but in this case, our resistors are parallel to the what? To the voltage. I wanna draw this. Now let's say this is our voltage. Now I'll still give it 9 volts. R1 here, R2 here. Now let's talk about the current that comes out from the source. Can you see now the path? Let's just follow the path from here now up to this point. Can you see that it wants to move into two directions thereof? Okay. Can you see that some of the current wants to move in this direction, whereas some of the current wants to move in that direction? But what's important is that at this point here, those two currents that have been split can do what? They now uh, come together and form the total current and goes back to the circuit. What do I mean? I mean this I total, when it reaches this point, it branches here into I1 and also branches there into I2. This is two paths. But when it comes at this point we have I1 combining with I2, and I1 combining with I2, it is what? It is IT. So at this point, moving from this point, going upwards there, we have our what? Our IT. Whereas here, I want you to see, whereas here, I'm still having my I1. Also here, I'm still having my I2. Only after this junction here, this point here, can we talk about what? About I total back. So we are saying now the first property is that the current divides. The current divides. So now I total splits, right? So it's gonna be I1 plus I2. Why? Because now it is shared among the branches. All right. Now what about the voltage? What about the voltage now? The voltage now, we say in parallel, now the voltage is the same. Why? Because they are connected parallel. You can take them as, especially agree you are doing a geometry, right? You are doing geometry. So remember the gradient of line AB and the gradient of line CD, gradient of line CD, EF. If these lines are parallel like this, it means they have the same what? The same gradient is the same. All right. Similarly, you can take a voltage as your what here? As your parallel lines. Why? Because now we are saying in parallel the voltage is the same across those branches. I repeat, in parallel, we are saying now the voltage is the same across the branches. This is what we say. And now we refer the parallel connection as the what? As the, sorry about that, let me do this and come back. We also refer parallel connection as the current divider. Do not cram this. Just follow the path of the current. It is the current divider, whereas here we call them, it is the voltage divider. Why am I saying this is a voltage divider? Because now the voltage should divide across, or should be shared among the resistance. Here I call it current divider because why? The current should be shared among the branches. All right. The second property is that V total, it is equal to VR1. It is equal to also VRR2. All right, that is the first important property therefore of voltage. And this one, people tend to do mistakes. Current should be very easy to follow because you just follow the path. All right. Now let's talk about resistance. Resistance, we say 1 divided by R parallel, it is equal to 1 divided by R1 plus 1 divided by R2. How are you going to remember this? Take this as a branch. Can you see it has a line here? So it means it is more like a branch and a branch here. A branch and a branch here. So you'll remember this, all right? When I'm dealing with something with a parallel circuit, now it means my resistance thereof will be more or less like that. All right? But but if use this formula, only, I should emphasize this, only only when you have two resistors in parallel. I'm not sure. Parallel, is it written like this? This formula that I'm gonna write for you, not this one, no. The one that I'm gonna write for you here. Which formula am I referring to? I'm referring to this formula. R parallel, it is equal to R1 times R2 divided by R1 plus R2. This formula, you only use it when you have two resistors in parallel. That is the only condition. If you have more than two resistors, you use this formula. Let me do this. Okay, you use this one when you have more than two. All right, I believe you're following. I want to believe this is fairly an easy concept that I'm explaining here. All right, now I won't explain many things. Basically, it's just us reminding each other of the circuits. Okay, this thing is starting to give me problems now. We are trying to remind each other of the these fundamentals here that are so important. Okay, this information here that I've written down here, it is very important, very important. Also, the one with regards to the series, it is this information is very important thereof. You're gonna see that when we apply, it will come up more. All right. Let me just warn you, there is no way that the examiner will just give you a series circuit or just a parallel circuit without combining them. That one I can guarantee you. No way. Let's talk a little bit about combination. Now let's talk about the combination of the circuit combination connection here. I'm gonna just do a simple one. Let's say now we have, okay, this is skewed. I want you to see something. I want you to see something here. Do you agree with me that so far let me just confirm time. All right. Can you see that so far we have a series connection because there is only one path? But the minute I extend this line here, like this, and input another uh, circuit there, this is now what we call the the combination. Why? Because now we have what? We have series here. But this is in what? In series. I'm sorry, we have parallel and series. Now, how can I confirm, Hore, which one is in parallel, which one is in series? Let's talk about the very same current. The current here, it is very important. If you get the current, you are done. Can you see that the total current, all the total current enters through R1, and the only time that when the current enters through a resistor, all of it, it is when we are having that component in series. Can you check? All the IT it is entering here, also entering here, entering here, and we said it is what? It is series. All right. So now it means now my R1, it is in series. Now, can you see, Mara, when I reach this point, my voltage wants to divide. The other one wants to take this route. The other one wants to take this route. Now, what does this tell me? This tells me now that R2 and R3 are in parallel. Why? Because now they cause the current, the total current thereof to split. When I reach here, I'm still talking about the I total, but immediately when I get to this point, I'll have I1 and I'll have what here? I'll have I2. So can you see that the resistor sorry, the current has split here into two branches. Then I said this is still my I2, this is still my I1. Then but immediately when they reach here, they just combine, right? I have I1 plus I2, which it is what? IT. Then I have my IT moving from this point to there until it goes back to my source and repeats the same cycle again. So those ones that share the current, we are saying they are in parallel. So we're gonna say R2, it is in parallel with R3. All right. So this is how we're gonna denote parallel. R3 it is R2, it is in parallel with R3. All right. Yes. Now, what about the voltage? The voltage, since well it is in series, remember what happens? Remember you said in series there is a voltage drop, so it means there might be a voltage drop here, right? Because it is in series, it should consume something so that it can glow. But there is a remainder of the voltage there, which is 4 volts. This 4 volts, what will happen? Is it coming here or is it coming here? But remember, the remainder will come on both of them. The 4V will come here. It does not split into 2V and 2V. No. This 4V, it is for this whole branch. Meaning this one will get 4V. Also, this one will get what? 4V. This is what I meant when I say, the resistance that are in parallel, the resistors rather that are in parallel share the what? The voltage. This is what we said there. This is what we said, that in parallel they share the voltage. Whatever the remainder of the voltage, actually they do not share the voltage, they have the same voltage. All right. So after the series has took or has taken its voltage here, now the remainder will be the same for those that are connected in parallel. All right. Yes, this is what I'm trying to explain now. The only time maybe it might vary, it is maybe when we have something like this. Let's say, uh, can you see now that these two are in parallel with this one? So now it means if this one has 4 volts, remember also these two should have what? 4 volts, then they can share them however. But as long the total here, it is equal to the total here, it is what we are looking for. So that's all for a revision of what we have been doing in grade 10. In the next video, it is where we'll be now talking about Ohm's laws and applying Ohm's laws moving forward. Yes, you did Ohm's laws, but now we'll be moving in depth with it. All right. So thank you.